All right, page 428, 1 and 2, we're just going to fill in the graph. So we're going to work over to the side. We're just going to plug it in. So y is 5 minus 2 times, the first one is -1. So that's 5 minus -2. So that's 5 plus 2 gives us 7. Next one, what about when it's 1? So we plug in 5 minus 2 times 1. So 5 minus 2 is 3. What about when the input is 3? So 5 minus 2 times 3, so that's 5 minus 6, which is -1. So when the input is 3, the output is -1. And the last one is 5, will come up here. So 5 minus 2 times 5, which is 5 minus 10. And 5 minus 10 is -5. So let's plot those points. -1, 7, that's our first point. 1, 3. There's our second one, 3, -1. There's our point. And the last one is 5, -5, which is right there. And if we draw a line through those points, or if we connect those points, we should get a straight line. We're asking, is it linear or non-linear? The answer is linear. Moving on to number 2. Again, we're just going to plug those in. So 2 minus x squared. So 2 minus -2, and we're going to square that. So 2 minus -2 times -2 is 4. So 2 minus 4 is -2. What about when the input is -1? So 2 minus, separate those, 2 minus -1, we should put the square on the outside. So that's 2 minus 1 is 1. So when the input is -1, we get 1. Moving on, the next one, 0. Well, 0 squared, we can still write it. 2 minus 0 squared. 2 minus 0 is 2. And 1. When the input is 1, you get 2 minus 1 squared. 1 squared is 1. So simply 2 minus 1. And 2 minus 1 is 1. And the last one, when the input is 2. So we'll come up here, 2 minus 2 squared. So that's 2 minus 4 gives us -2. So let's plot those points, -2, -2. There's our first point. Next one is -1, 1, 0, 2, 1, 1, 2, -2. So if we were to connect these points, it would look something like that. And that is nonlinear.